Welcome to Theory of Computation class. Today I am going to explain the pumping lemma technique in context-free language. So, in Unit 2, the same pumping lemma technique was used in a regular expression. The rules will be varied, but the same applications is used in the CFL also. So, third unit contains a context-free language and a context-free grammar. Using that only we can able to construct a parse tree or derivations ambiguous. So these are all available. The same set of context-free grammar is used for construction of normal form. So in this problem we are discussing that whether a pumping lemma technique is applied to a CFL or not. So normally a pumping lemma technique is only used for proving not regular or not CFL technique. So if you consider any formation of a string of a particular language, so that string should be a valid string in a given language. We should take that 5 different formats. That is, at least 5 symbols should be available in a given language. So like that only we should consider capital Z as a string which contains 5 substrings in it, which are all namely U, V, W, X, Y. If it is framed, then this should be satisfied with these 5 rules. First rule is mod Z value should be greater than or equal to N. Mod V value, V is also a substring of Z, that should be greater than or equal to 1, which means that at least one symbol should be taken for V substring. Then mod Vx value should be greater than or equal to 1. And fourth rule is mod Vwx should be less than or equal to N. Then if 4 rules are satisfied, then we should take I value should be greater than or equal to 0, which means that Z will be formed as U, V power I, W, X power I, Y. If you frame these type of notation, that not should be in a given language. If these 5 rules are satisfied, then we proved that the given language is not a CFL by using this pumping lemma technique. Let us discuss the problems further. So this is the first problem. I am taking the first problem as L is equal to A power n, B power n for all n greater than or equal to 1. You should prove that it is not CFL. First you should write the correct strings for a given language. For substituting n is equal to 1, the string is AB, 2 means AA, 3 means AAA, 4 means 4A, 4B, like that. So all strings contain equal number of A's and B's in it. We should frame Z value. Z should be U, V, W, X, Y. So minimum 5 symbols should be available. So I am not able to take the first 2 symbols. So either we can take the strings from 3rd or 4. Here I am taking the 4th string. If you want to frame the 4th string, n value should be 4. So if n value is 4, Z is equal to A power 4, B power 4, which will be rewritten as 4A, 4B. The first 4 symbols will be treated as U, V, W, X. Then the remaining 4 symbols, 4 B's are treated as a substring Y. So I am writing it as separately. Then what are the rules? First rule should be mod Z greater than or equal to N. Mod Z means the length of the string. So what is the length of the string? The given string is 8. I am taking n value as 4. So 8 is greater than or equal to 4. First condition is satisfied. Second condition, V value is 1. Mod B value is 1. So 1 greater than or equal to 1. It is true. Vx, V value is A. X value is A. So the length of Vx is 2. 2 greater than or equal to 1. It is true. Vwx. These 3 value, the length is 3. N value is 4. So 3 less than or equal to 4. It is also true. Then for all I, Z should be the generalized form is U, V power I, W, X power I, Y. So for example, I am taking I value equal to 3. So it starts from I is equal to 2 onwards. If you substitute I is equal to 1, the same Z value symbols will be available. So we should take I value is from 2 onwards. So instead of 2, I am taking I is equal to 3. So the notation is U, V cube, W, X cube, Y. So you substitute U, V, W, X, Y values from the given notations. So the answer is A power 8, B power 4 but the given language should contain equal number of A's and B's in it, but the resultant answer is not in a given language, so the given language is not CFL. Then the second problem, L is equal to 0 power n squared for all n greater than or equal to 1. Otherwise, it will be taken like this, k where k equal to I squared. So I am taking n is equal to 1 means 0 power 1 squared is 1, so 0. 2 squared means 4, so 4 zeros. 3 squared is 9, so 9 zeros. We should take z value should be at least 5 symbols, so I am not able to take the first 2 strings, so I am taking the third string. If you want to frame the third string, the n value should be 3, so n is equal to 3, z equal to uvwxy. So I am substituting first 4 zeros as u, v, w, x, the remaining 5 zeros for y. Then you check these conditions. At last, the fifth notation is z equal to u, v power I, x, w, x power I, y. I am taking I is equal to 3, which means that 0, 0 cube, 0, 0 cube. The y number of zeros are 5, so I shortly write it as 0 power 5. So 5 plus 3, 8, 8 plus 1, 9, 9 plus 3, 12, 12 plus 1, 13. So n squared value, so there is no n squared value with 13, so it is not in CFL. So the given language is not a CFL by using this pumping lemma technique. So I am going to take the third problem, 0 power p, where p is prime number. So number of zeros should be in a prime number. So prime number starts from 2 onwards, 2, 3, 5, 7, 11. Either you take the third string, otherwise fourth symbol. I am taking the fourth string. So for framing the fourth string, n value should be 7. Z is equal to u, v, w, x. Those values are single zero, and the remaining 3 zeros will be treated as y. So use the same rule. Here I am taking I is equal to 2 as a minimum value. So 0, 0 squared w, 0 squared y value 0 power 3. So 3 plus 2 5 plus 1 6, 6 plus 3 9. 9 is not a prime number, so it is not a CFL. And the last problem in pumping lemma technique is the generalized form. A power n, b power m, c power n plus m. So you can able to substitute n and m with different values. The starting value of n and m should be 1. So I am taking n and m values are equal. So if those values are equal, the answer is a cube, b cube, c power 3 plus 3, 6. So in which u is a, v is a, w is a, x as b. The remaining double b, 6 c's will be treated as y. Apply the same rule. For the fifth rule notations, I am taking I is equal to 2. So the generalized form of z is equal to u, v squared w, x squared y, in which I should substitute u, v, w as a, x value as b, y value as double c, 6c. So if you count it, number of a's are 4, number of b's are also 4, but number of c's should be 6 for these conditions. But it is not satisfied in a given language, so therefore it is not a CFL. So in this way, you can able to solve these 4 problems. So I am going to give it these problems as a homework. So you do it by yourself with a different n and k values for solving these problems. The next concept in context-free language is the closure properties. I already give an explanation of closure properties of regular expression. The same notations, theorems can be applied for a context-free language also. So I already given an explanation for these 4. Union of 2 regular languages regular, concatenation of 2 regular languages regular, then homomorphism, inverse homomorphism, format, intersection, difference, reverse of a language is also reverse. You can able to explain the same concepts for the context-free language also. This is the way the first part of Unit 4 will be over. From the next class onwards, I am going to take the second half of Unit 4, which comes under a topic Turing machine. Okay, thank you.